right? I know we didn't spend tons of time on that, but remember, up here, what is this up here? Dude, help me out. What do we call this thing? This is our lesson. This is our title, right? We don't have to actually do these things. This is just where you find the info in your book. Okay, your learning goals, cumulative review. All right, let's see if we can figure this out. What do you have to have in order to add fractions? Common denominator, very good. What's common denominator? 9 and 2? 18. So what times 9 is 18? 2. So what do we have to do here? Multiply the top by 2 also. That gives us 4/18. And this, what times 2 is 18? 9. And so 3 times 9 is 27. 4/18 and 27/18. So now we're counting 18s. How many 18s? We have 31. Now in math, a lot of times we just leave that improper fraction because, or in algebra we do that a lot because we're able to plug that as somewhere else. We do that in geometry as well. So I'm going to leave it as 31/18. Okay, I'm not going to change it to a mixed number. This one I can kind of do in my head. If I have 4 and I subtract, let's ignore the 1/4 for a minute. If I have 4 and I subtract 2, what do I get? 2. And then if I take another 4th off of 2, what do I get? 1 3/4. Yeah, man. Do I need a common denominator when dividing? Don't need a common denominator when dividing. But what I could do is I can change this to multiplication and flip this one. That gives me 2/5 times 10/1. Our minds usually work better when we're doing multiplication than division. So what happens here? We cancel. That becomes a 1. That becomes a 2. And we're left with 4. All right. So we've talked about addition, subtraction, multiplication, and division, all with that. I'm going to end right there for today. Okay, we won't always finish them all, but there we go. It's a quick review of some fraction stuff. All right. So today we are diving into our, let me put this back up here for a minute, 1.2. What I want you to do is go ahead and turn your note page over, and I want you to fill out at least the title. So I'll put one of these up here just so that we're clear on how to use these. Sometimes we'll use these, most of the time we'll use these. Sometimes we'll be just in our journal. But we know we fill out our name, obviously you know that. Section number, so McCoy. Section number is 1.2. What's our title? Good. Measuring and constructing segments. Pages 11 through 18, and today's date, 9/11. Okay. Good deal? Let's explain how we use this note page here. Actually, we'll explain how to use that here in a minute. All right? How many of you used Cornell Notes before? Like this. Okay, very good. We'll go through that here in a minute. All right. Hey, just so you know, in your student journal, there's this page. Why don't you open your student journal up real quick. There is an actual notes section for you. Most of you know that already. But there's a place for you to, this is on page 9. There's a place for you to take notes. There's a place for you to define words, which you can do. I'm not going to go through that with you right now. I'm going to go through a few other things with you. But there's a place for definitions. There's information about some of the postulates. So you don't have to, when you see a postulate or a theorem in the book, you don't, unless you want to copy it down in your own words, you don't have to recopy everything. You can just go in here and kind of edit and add your own wording to it. Make sense? So when we're doing notes in here or working through problems on our note sheet, you may want to just have your journal next to you so you can make notes in it as well. All right? So I'm not going to touch on that right now, really. Here's page 10. Page 10 talks about different postulates, and most of these postulates, the ruler postulate and the segment addition postulate, I'm going to hit on those as we go. Okay? But I'm going to let you read through that on your own, at your own pace. One thing that I did want to touch on is these two things, though. Okay, if you see this symbol right here, that symbol means congruent. It's like the cool equal sign. It's a equal sign with nice hair, if you think of it that way. Okay, so that means congruent. It means they're equal. It means line AB, or segment AB, excuse me, is congruent to segment CD. The way we write it, it looks like that. The way we see it on paper, it has a segment with a little slash in there. That means they're equal. This segment with one slash is equal to that segment with another. They're congruent. That's how we show it in geometry. Okay, so what I want to do is I want to work through some problems. So these problems that I'm showing up here, you can kind of work through and put your answers on your sheet right here. So let's go ahead and measure this real quick to the nearest centimeter. Now my measurement's going to be a bit different than yours, and just so because my paper's a bit different, okay? This would be example. Oh, you guys need to open your textbook. Sorry, page 11 in your textbook. Your textbook. Oh yeah, that's the big heavy book right in front of you. Page actually it's probably on page 12. Okay, page 12 of your textbook. You'll notice mine may be a little different length than yours because mine's printed off. Yours is scratched out? Oh, your ruler. It's actually on page 12. Hey guys, when you're measuring in centimeters, you'll notice at the very end of my centimeter ruler, it kind of gets cut off. So what I'm going to do is I'm actually going to try to start there in the middle of that dot and kind of measure over. But for me, to the nearest tenth, mine looks like, I'm going to assume that it starts at about the right spot, knowing it might be cut off a little. It looks like 4.4. What do you guys get? Yeah, mine's a different length. Okay, so you guys, yours in your book's going to be a little different, but go ahead and take turns measuring on your book there. 3.5? Anyone agree? 3.5? Okay. Hey, let's switch over to the bottom of that page. Go down to the bottom to the monitoring progress. Huh? 3.4. It might be because that little piece on the end is cut off. You know what I'm saying? No, I mean on ours. Depends on the rulers. Let's go to the nearest inch. Now you'll know, like I said, sometimes it looks like it's cut off. So if you want, you could always start at 1. Just remember. So if I'm measuring this to the nearest eighth of an inch, for those of you who don't know, if this is my inch ruler, a ruler is usually broken into 16 equal parts when you're dealing with inches. Each of these little lines is 1/16. That means 2 of those lines is an eighth. So there's 1/8, 2/8, 3/8, 4/8, which is a half, 5/8, 6/8, 7/8. All right? So if I'm going to the nearest eighth, if I start at 1, I put the 1 in the middle of the dot and move over, I have 1 inch, 2 inches, and 1/8, 2/8. I have 1 and 2/8 on mine. Now yours is going to be different. By the way, 1 and 2/8 is, I'm sorry, I have 2 and 2/8. 2 and 2/8 is 2 and 1/4. What do you guys get? Each of you measure it with your groupies, see what you get there. All right, sounds like 1 and 5/8 what you get. That kind of the consensus there. Hey, any questions on that? All right, so we're just kind of measuring using our ruler there. Okay, the next problems I'm not going to do any other examples with us right now. I'm going to kind of work us through some of the stuff off of our assignment today. Okay, let me give you the assignment. We're going to kind of take a look at some of those and work through them together here. That's our assignment, so I want you to look at it there while I'm handing it out. So let's go ahead and take a look at this. I want to start on number 3. First thing we're going to do, I want you to plot all those points. Number 3, plot all those. Just remember that x comes first, so x is -7. Y is 1. Point A. B is -4. And Y is 1. There be B. C is 3. -5. And D3, -2. All right. Plot the points in the coordinate determine if AB, so connecting AB, is congruent to CD. Straight lines, if they're horizontal or vertical lines, it's easy to find the distance. We just count them up, right? What's this length? 4? Yeah? For sure? Think so? So from A to B, everyone agrees it's 4. Yeah, I think it's 3, right? You go 1, 2, 3. You're counting the spaces. 1, 2, 3. Not counting the dots, right? So here, how far? 3. 1, 2, 3. What's that? So it's going 1. Sorry, I meant 1. So from there to... Yeah, you don't count the first one. I was? Okay. All right, so are they congruent? Yes, congruent. All right. I want everyone to look at number 5 there. Hey, I'm sorry. Any questions on that? Did I confuse? We're good? Okay. Yeah. If they're the same length, they're congruent. Yeah, for sure. Number 5. I want you to find ST with your groupies. Figure out what you do. Okay, how many of it? Anyone tell me how to find ST? We're not measuring. They've already given us lengths. Annika? Subtract 4 from 22. We know if the total length is 22, and we know this part is 4, that means that much of the 22 is 4. That means this much of the 22, or ST, has to be 18. So you're doing 22 minus 4 to get 18. That is the ruler postulate. You're using the ruler postulate right there. Or excuse me, you're using the segment addition postulate. So this postulate 1.2 from our student journal on page 10, all that right there is telling you this. It says if this plus this, or if this ST and TU make up SU, then this length plus that length must equal that length. How many already knew that? And most of you know, like, if 2 pieces make up a whole, you add those 2 pieces together and you get the length of the whole. Okay. No labels, yeah. You can put units if you want. Make sure you circle. All right, turn it over, please. Why don't you take a look at number 9. Number 9. Exercises 9 and 10. B is between A and C on segment AC. So draw your picture real quick. I'm going to draw a picture of that. Just that first sentence. All right, show your neighbor your picture. Okay, what point would this be right here? A. What's this? C. And what's this? B. Very good. That's what that first sentence says. Use the information to write the equation in terms of x. Well, if AB, if the length of A to B is 13 plus 2x, and the length of BC is 12, and the length of AC, so from here to here, is x plus 32. We need to write an equation to solve that. How many of you can see the equation? What has to make up x plus 32? Cynthia? Good. These 2 pieces make up this. Now I'm putting parentheses just to show the different pieces. And then we can solve for x. Once you solve for x, then you have to find A, B, and BC. So if x equals 5, which I don't know if it does, if x equals 5, we'd have to put 5 in for x here and find that AC is 37. Okay? All right. I want you guys working on this week, and this is your assignment. do on Monday. Ooh, remember, you have online resources and your textbook to help out as well. You can send me questions if you got them.